Hey guys, coterminal angles. So the concept of coterminal angles I told you before was this, and it's the idea of having co-terminal, or same terminal arms, okay? So if I have a terminal arm from a positive rotation from my initial arm here, initial arm, always along the positive x-axis, rotated, rotational angle, up to my terminal arm, okay? And my terminal arm is always the place where we end up. And if this angle, let's make it real easy. Let's make it 30 degrees. Real simple. Well, I can get a coterminal angle. Another angle that has the same terminal arm, coterminal, like co-worker, you both work at the same place. If I was to go all the way around 360 and then up 30. So 360 plus 30 is 390. That is a coterminal angle. And I could do the same thing if I went around twice, 720, and up 30 more. So 720 plus 30 is 750. They're all the same terminal angle. And I can get the same terminal angle if I go this way and stop. So I'm going negative 90, negative 180, negative 270, and then all the way up to, but not including this 30. So instead of 360 degrees negative, I'm just missing it by 30, it would be negative 330 degrees. And following the same argument, I could go all the way around negative and then pick up the 330. So negative 330 plus another negative 360 is going to give me negative 690. So negative 690 takes me to the same coterminal arm. So to get here, there's an infinite number of choices I could have. I could get there by going 30 degrees, 390 degrees, 750 degrees, and what that means is 360 degrees plus a whole bunch of more full angles. So plus 360 degrees n, where n can represent the number of full rotations I want to go through. So we could call that, it's a member of the whole numbers. So we could go 1, 2, 3, or it could even be 0. So we have to take that into account. If n is 0, then it's just the 360. So this is an expression that represents all of these numbers going all the way up. We also have to take into account that we could have had negative 330 degrees, negative 690 degrees. And so that will be negative 330 degrees minus, or adding more negatives, 360 degrees. All the way for n being 0, 1, and 2, or 3. And we can put these two things together by saying that our answer could be, well, no, we can't put them together. So one of them's got to start at 30, the other one's got to start at negative 330. So if I wanted to talk about all of the possible answers, these are the expressions I would use. Now, the smallest positive answer, the one in quadrant 1, is what we call the principal angle. And yes, it's spelt the same way as principal of a school, because it is the big boss. So it is the principal angle for all of the other coterminal angles. And a principal angle must be between 0 and 360 degrees. I think I said in quadrant 1 earlier, I lied. This one happens to be in quadrant 1. But a principal angle could be outside quadrant 1, but it's got to be only directly to it. So a principal angle, for example, grabbing another piece of paper. So let's say I had down here. And so that would be, I'm going to make this up. Let's say that's 180. So let's make this 200 degrees, okay? So that means that this is 180. That means that this little bit is 20, right? That means that what's left here is 90 minus 20 is going to be 70 degrees. So to get here to this terminal arm from this initial arm, we could have gone 200 degrees. Or you could have gone all the way around 360 plus 200. So 560 degrees. Or you could have gone all the way around twice, 720 plus 200. So that's 920 degrees. And that would continue on and on and on. We could demonstrate that by saying 200 degrees plus 360 degrees n, where n is an element of one of those nice numbers. We call them the whole numbers. Or we could have come this way. Notice that that would have been negative 90 plus 70. So that would be negative 90 plus another negative 70. So that would be a total of negative 160 degrees. So this would be negative 160. That extra 20 would have brought you to negative 180. So that makes sense. Or we could have added another negative 360, gone all the way around. So that would have been negative 360. Take away 160. Negative 520. Or we could have gone all the way around. Negative 720. Take away another 160. Negative 880. All of these are coterminal angles. A formula to get all of these would be negative 160, take away 360, n. Where again, n could be no rotation, one rotation, two rotations, and that will multiply it out. So, we have a whole bunch of answers. We have, to be able to go from here to here, on what I have listed is I have 200, 560, 920, and there's more. But we also have negative 160, negative 520, negative 880, and there's more. So we have one angle that we call the principal angle, and it is the smallest positive angle that goes between 0 and 360. So this is what we call the principal angle, and all the rest get called coterminal because they share the same terminal arm as 200 degrees. They're all going to end up here from here. Just matters how many times around we go. Okay, so let's take a look what I have here. So as the point x, 1 rotates around the circle, it will repeat its position by adding or subtracting multiples of 360. We've talked about that. The resulting repeated angles are known as coterminal angles. We've talked about that. This shows that if theta 2 equals my first angle plus a rotation, where n will represent the number of rotations that we go. Now, coterminal angles, let's see here. 4 rotations around the circle. Then theta 1 and theta 2 are coterminal angles, and sine of theta 1 and sine of theta 2 will have the same values. Well, this is true. So if I have a rotational angle that are coterminal, so let's take a look at one. Let's put one out here. Okay, so let's call this, well, no, let's make this a little bit easier just for fun. Let's make this 30 degrees. Okay, so there's your initial arm. There's your terminal arm, and we'll make that 30 degrees. So the sine of 30 will equal opposite over the hypotenuse, which is r, the radius here. So it's going to be the opposite over r. Now if I do another rotational angle, so if I go 360 plus 30 to 390, notice my triangle hasn't changed. I still have opposite over the hypotenuse. Notice if I go the other way around to negative 330, then my triangle hasn't changed. I still have opposite over hypotenuse. And that's what they're trying to say here. Now, something else that probably warrants talking about. For this one, I've said that we could go 30 and we could go 30 plus 360n where n can be 0, 1, 2, 3, all the way up. And I then would have said to you that theta could also have been negative 330, and we would find that by negative 330, subtract 360, n, where n is an element of 0, 1, 2, 3, etc. That's the way I've shown it in the last video. However, in that last note, it shows it a little bit differently, and they do that by noticing that 360 can be found using my principal angle by taking the principal angle and subtracting 360 degrees. So here's my principal angle, and I'm going to subtract 360 from it. That'll give me the negative 330. So what this means is that these two different formulas can be put together to give me all of the coterminal angles here by starting with the principal angle, and instead of just adding 360, if I subtract 360, I can get all of the rotations. And some people in some textbooks will get rid of this plus or minus, and they'll just make it plus. But what they do is they change this n to an integer. Whether they say so or not, what they mean is that this n can now be all the numbers negative and positive that are the whole numbers, which allows this to become negative. So if this is negative 1, that becomes negative. So these are two ways of saying both of these at once. Okay, let's go back to our lesson. So example, if theta 1 equals 30 degrees, hey, that's the one I did, then I could go all the way around and do 360 times 1 or get 390. Yeah, that's the same example that we just did. I like what we did better. Okay, so example 2. Find two coterminal angles for each of the given angles. Well, this is pretty easy. I do suggest that you do a little bit of a visual because it does help a whole bunch. 75 degrees, that's 0. That's 90. So 75 degrees is somewhere in here. So that is my principal angle. That's what they gave me. They want two coterminal angles. So one of them would be to add 360, go all the way around. So 360 plus 75, 435. And if they told you to draw it, you would actually draw all the way around and then back up. And another choice would be 75 degrees plus 360 plus 360. So go all the way around twice, which will give me 795. And again, if you ever get a question that says that you have to draw it, honest, this is what you draw. All the way around once, all the way around twice, and then up. We also could have had the negative coterminal angle. Take away 360. So instead of going up to 75, we could have come this way. And instead of coming all the way around to negative 360, we would have stopped short. So it would have been negative 360, stopped short of 75, which would have been 285 degrees, but negative in this case. So I gave 3 answers when they only wanted 2. You could pick any 2 that you wanted and you'd be good to go. 120, again, I do suggest that you draw it, although you probably don't need to. This is 90, this is 180. So 120 is here, guys. So 120 is your principal angle. 2 rotational angles would be 120 plus 360, which will be 480. And another one would be 120 going the opposite direction. So that would be negative 240. So again, negative 240 is here. Whee! And 480 is all the way around positive and then there. All right, that's it for example 2. I'll stop here and then do the last page.